Hi, I'm Tony,
I'm Jacob.
I'm Kevin.
and we are Team 287 from Seicho School in Newport Coast.
So our project, we are building a below-knee prosthetic for those with lower limb differences, and we're aiming to produce a cheaper and more mass-producible product.
Our design is almost going to be something like a almost do-it-yourself. We're seeing where this project is really going to take us. We have a CAD, but as you can see, it's a very rough CAD. This CAD was just to get a general idea of any issues we might run into, any problems we might do. And we're planning for our design to be pretty cheap. We're trying to use
Including some mountain bike shocks over here, and over here we will have two shocks, one air shock and one more spring shock. We will also be using carbon fiber nylon to hopefully print a sole for the prosthetic, as well as using 3 or 4 rods, linear rods. And Jacob will explain more about the mechanisms themselves.
So as we mentioned before, we're really aiming for like a really easy kind of almost where one could build it themselves. We're trying to aim for a lot of our parts to be either 3D printed or pretty much manufacturable like at home. But as you can see, that would run into some issues, especially with joint strength, especially for these joints. And also just in terms of the linear rods, we need to do some definitely prototyping and testing to see how strong they are. But here's an overview of our design. Our design is really broken into 2 main components. Our first component is just going to be a simple suspension mechanism. This will be done with an air shock. We're choosing to use an air shock, like an air mountain bike shock, because of the adjustable air stiffness, and because we're hoping that this shock will be pretty rigid, and we're not looking at more than maybe, I think the max travel could be less than an inch, and the normal travel while walking could be a quarter to half an inch. So
Around
we're looking
250 pounds of force and max.
Yeah, around. We're gonna test out different forces. We're supporting this mechanism, so we're trying to make everything not rely on like singular joints to be really strong. So we're supporting this mechanism with some linear bearings and rods. We're thinking of switching from 3 to 4 right now. This is just a small thing just for weight, because that is another big thing we got to aim for.
We want to try to keep the design overall under 5 pounds, because a normal below leg, the area below your knee is usually 4 pounds. So we're trying to aim to have our whole prosthetic foot under 5 pounds and a max cutoff at 6 pounds.
Yeah, and also these parts, we are hoping, these 2 bodies that we're highlighting, we're hoping to maybe 3D print them, just because of the relatively low, I guess, strength and compressive strength that they'll have to undergo. And as he mentioned before, we're going to use carbon nylon, hopefully, if we can get the funding for that, to pretty much just make it as strong as possible. Another thing is so the first component was the suspension. The second component is going to be the ankle mechanism, and this is the mechanism that I think we need the most work on. I think the suspension mechanism so far I personally, I think it's a very solid mechanism. I think that this could go to the final one. Our current ankle one, as shown in the CAD, I think will definitely not. So right now we have a sort of 4-bar kind of mechanism where this whole body will actuate forwards. This whole body will go forward and backwards. And also, so we're planning on pretty much simulating the modes of walking. I guess in general, I think this is a big area of improvement for us, is the ankle, and also we need a model. I think right now our heel strike and our mid area pretty much walking is good, but for I guess just the toe kind of pushing up, we need to do more research, and we need to just design a mechanism, maybe some kind of locking, maybe some kind of foot design. But there is still a lot of improvement to be done.
Yeah, and we also plan on using tools such as finite element analysis in order to measure the like various forces that are exerted on the foot. We're also we're trying out new methods for actually like fitting these this foot to recipients, and we plan on using like 3D scanning technologies.
Or even like molding, so that each person can have like a perfect fit for their leg, and so it's also more comfortable for them to walk in as well as just exercise in general.
So like as they mentioned, we're trying to make this ankle pretty much be, I guess, universal for really any recipient. It doesn't take up much room. It's maybe this tall at a maximum. So we're hoping that the co-designer that we will find will, we will just build a structure off of this. Some kind of, obviously we need to prioritize comfort and sturdiness because all of this would pretty much be minimized if those weren't a thing. So yeah, we're thinking of either doing a 3D scan or maybe some kind of cast and just building off of that.
Yeah, but that's basically an introduction to our project. This is just, for example, a video. I'm gonna put it on the screen real quick, but this is a video of the simulation of someone walking in our prosthetic foot.
For the materials we are requesting to buy some carbon 3D printer filament. We think that this will be helpful and necessary for strength and also lightness. We hope that because it's somewhat expensive, maybe like around $40 a spool, we're hoping that maybe BWSI could buy it for us. We also want an air shock, as we have seen in the design for the suspension. We think an air shock is necessary, and we're thinking of a mountain bike air shock because of the variable shock load. And we are also requesting one more thing, which is some kind of spring shock or just spring in general, which we need for the ankle joint, and which we have already explained earlier in the design. Thank you.
And yeah, also the linear rods.
We also want some linear rods for the suspension again. These are cheaper, but I think it will be helpful for us just for rigidity and strength for the suspension mechanism. Thank you.
And then, sorry, finally we have the silicone rubber for either the sole of the foot, below like the 3D printed foot itself, and maybe even for to like mold the leg. I don't know if that makes sense, but yeah.
For like comfort of
For comfort of the
connecting.
recipient, yeah. But yeah, that's about all. Thanks for watching.